Yo, everybody, welcome to the Phallus family. In this segment, I will be your guiding light here. My name is Mr. Phallus. I am a third grade teacher at Roseline Condon School. I teach math and science there, but today our focus is going to be on math. What we are going to be doing during this time is using the remote packet and playing the Prodigy game. So maybe you do have a device that you could log on to Prodigy with. If you'd like for me to set you up an account so you can play along with us, here's my information. You can follow me on YouTube at Jacob Phallus, or you can email me or have your parents email me at phallusj@cpsboe.k12.oh.us. And as I said, we are going to be playing the Prodigy game. It is going to focus on math, and I'm going to use what is in the remote packet to help support learning at home. Again, if you have a device, go ahead and send me an email or follow me on YouTube, leave me a comment. I will set up a program for you so you can play along with us as we get through this remote packet learning. So, without further ado, let's get started on the game. All right, today in our Prodigy game, we are going to be focusing on a key skill. So I want to get an I will statement. I know that you do these all the time in school, and if you don't, you're doing them right now. So if we look here, I will dominate addition and subtraction by finding the sums and differences between two numbers. Maybe we got three numbers, but today it is a focus of two numbers. So repeat after me. I will dominate addition and subtraction by finding the sums and differences between two numbers. You should have said that out loud. Here we go. You should get a little notebook, piece of notebook paper, and write down because we're going to be focusing on two key vocabulary words. The first one is sum. Sum is the answer to an addition problem. All right, the answer to an addition problem. So what is the sum? The sum is the answer to an addition problem. The next vocabulary word we have for today is difference. All right, difference is the answer to a subtraction problem. All right, one more time. Difference is the answer to a subtraction problem. You should have those two terms wrote down in your vocabulary notebook, and let's get started with this game. By now, you should have went to Jacob Phallus on YouTube with your parents' permission and subscribed to my channel, or you could have went to my email address and emailed me your first name and last initial so that I could set up a username and a password for you so that you can play along with us. If not, you should be getting a piece of paper and a pencil or a dry erase board with your little dry erase marker so that you can work through these problems as we begin to play this game. So let's get started here. You will go to Prodigy, that is Prodigy, in your web browser, and it'll show up something like this. We are going to go and we are going to go down here and click where it says play Prodigy right here. We're going to click play Prodigy. So we'll click play Prodigy here, and we will be prompted to a screen that looks like this. You do not need to sign up. If you sign up, I will not be able to help you out and help work through these problems with you. But if you choose to follow along with me, you are going to hit the login button here. So we're going to go to our login button. Then we will be putting in our username and password, and I already have one created. Mine is teacher F104, and I'm not going to tell you my password because some of us might get logged in here, but we will go to the login screen. As you notice, we are getting to the login screen here. All right. And we will be selecting our own wizard. So I'm a guy. I'm going to select this wizard over here. All right. Going to change my hairstyle here. All right. I like it. My eye color. I'm going to have some crazy, nice little blue eyes here. My hair color. Let's go with the brown hair color, and then my skin color. I'm going to go ahead and do here. And then I will scroll down and I will click the next button. All right. Now, you are going to be playing from school no matter what, because even during this remote time, we are going to be playing from school. So I'm going to click the school button. All right. Parents, if you'd like to sign up for an account, they will prompt you to do this, and you can link the account and all that good stuff. We can talk about that on a later day. So I'm going to go ahead and hit play here. So this is my house. Now we're going to go and hit the next button. Uh-oh, going to the academy. Here we go. Getting out of bed. What's up, noob? So at this point, you're gonna select a name. Maybe your name's not on here. All right, I'm gonna look for Jacob on here. Jacob. All right, so they got my name. If they don't have your name, pick a name of your choice. It doesn't really matter. All right, they're just selecting the answer. Let's go. All right, let's battle then. All right, so at this point, we're going to cast our little spell here. All right, I'm choosing this one. Then our first problem. So in math, we want to read, we want to write, and we want to draw. So get your piece of paper ready. So if we look here, it says complete each pair to have a sum. If you don't know what a sum is, all right, we can look here. All right, the sum is the answer to an addition problem. Write that down if you need to. The sum is the answer to an addition problem. So what this is asking me is 2 plus something gives me 3. 2 and another number give me 3. So if I look here, all right, I am going to use my little resource tools here. All right, so I can go over here and I can select my color. All right, so I got 2. All right, 2 plus another 1 in this case is going to give me 3. All right, I know that I can put 2 fingers up plus 1 finger. I put them together. 2 plus 1 equals 3. And then I can say 2 and 1 give me 3. So in both cases here, I've just switched. I've done what's called inversing the numbers. And then I'll come down here to cast my spell. All right, there we go. Moving on to the next one. Let's see what happens next. All right, gonna hit my spell again. Here's my next problem. Again, what is the sum? The sum is the answer to an addition problem. You try it. What is the sum? The sum is the answer to an addition problem. So I'm looking for 2 numbers here. So this time I'm going to use a little bit different. I'm going to say 17 minus 10. So I'm going to come over here. I'm going to pick a different color. I'm going to do 17 minus 10. All right, 17 minus 10. What I like to do is I like to separate my numbers into place values. So 7 take away 0. I know that one all day is 7. All right, 7 take away 0 is 7. 1 minus 1 is 0. All right, so I know that 10 plus 7 would give me my sum of 17. And remember, sum is the answer to an addition problem. I go to my next problem here. This time I have 17, and I'm going to need to subtract it from 9. Why? Because that's the number that I know. And again, I like to separate my numbers by place value. So I have the tens place and I have the ones place. So 7 take away 9. Uh-oh. The bottom number is bigger, so I have to borrow. So I'm going to take this 10 and I'm going to move it over here. So now I have 17 minus 9. So I can use tons of different strategies. I'm going to use the count up method. So I'm going to start with 9 in my head. 10, 11, 12, 13, 14, 15, 16, 17. So if I look here, 17 minus 9 would give me 1, 2, 3, 4, 5, 6, 7, 8. And I plug 8 into that spot right here. And now I have 11. All right. So I'm going to hit the trash can again. All right. I have 11. So I'm going to do 17 minus 11. Again, separate by place value. I got my 10s over here. I have my 1s over here. 7, take away 1. Again, this time I'm going to use the countdown method. All right. So I'm going to start at 7 and I'm going to count down to 1. So I got 6, 5, 4, 3, 2, 1. How many dots do I have? 1, 2, 3, 4, 5, 6. All right, so I have 6. So if you got these pairs, go ahead and give yourself a pat on the back, and we will cast our spell here. Correct. Uh-oh, missed. All right, all right, all right. Here we go, casting another spell. Our next problem is it says complete the pairs to have a difference. Difference is a new word. All right, difference is a new word. So difference, unlike the sum, so difference, write this down. Difference is the answer to a subtraction problem. So the difference is the answer to a subtraction problem. You try. What is the difference? The difference is the answer to a subtraction problem. So if I look here, this time I'm trying to create pairs that have a difference of 1. So what I'm trying to say is 4 minus something, in this case 1, all right, is going to give me the answer of 1. So I can just plug this in. All right, I can plug this in. So if it's on the left side, I'm going to take it. 4 minus 1. 4 minus 3 would give me 1. All right, 4 minus 3 would give me 1. So the answer to that one is 3. Now, this one is a little bit different. All right, a little bit different because I have a number 4 right here. So I'm trying to figure out what and 4 would give me 1. So I can use the reverse method. So I can count up from these numbers on the right side to give me my number. And I can say 4 plus 1. What does 4 plus 1 give me? 5. And I can check those answers by simply saying 5 take away 1, or take away 4, I'm sorry, equals 1. All right. I know that all day, every day. Read, write, draw. If you don't read the problem, you can't get the problem right. All day, every day. So if I look here, I can check my answers before I hit cast my spell. 4 minus 3 gives me 1. And 5 take away 4 gives me 1. So I'm comfortable with that. Here we go. All right, now we have won our first battle. Go ahead and give yourself an 8-finger woo. It's going to sound like this. Woo! Let me hear you. All right, so it says we gain 100 hearts. So let's keep playing the game here. Open my chest. It looks like I got some money. Hallelujah. Thank you. Thank you. All right, we got gold. So I'm going to hit my little X here. I'm going to continue on with my game. All right, so we're going to follow the magical guide hand if we don't know what to do. All right, so at this point, I'm going to pause for a second and I'm going to go ahead and move on to the next part of our game. So, in review today, we covered sums and differences. You should know that the sum is the answer to an addition problem. You should also know that the difference is the answer to a subtraction problem. Make sure that you have ingrained that in your mind. Make sure that you have wrote that down. It should be review at this point. As always, thank you for tuning into my segment. I hope to see you again in the very near future. Again, as a reminder, please have your parents subscribe to my YouTube channel at Jacob Phallus. Every day I will post updates and all that good stuff for you, as well as email me at phallusj@cpsboe.k12.oh.us to get your free Prodigy account so you can play along with me as we navigate through these questions. I'm not going to get them all right all the time. That's just not how I play. I know in the next segment I will get some wrong so that you can see what happens when you get things wrong and some of the other resources you can use on Prodigy to help make yourself successful. If you don't like drawing on the screen, like I am being forced to do, pick a piece of paper up and draw your problems out there. The number one way you're going to be successful in math is by reading the problem, by writing out the problem, and by drawing the problem. If you are able to do those three things, you will be successful in math. It doesn't matter what grade you are in. If you can read the problem, if you can write an equation, you can write some sort of method to solving the problem. And if you can draw a picture to go along with that, you will be successful. As always, I believe in you. I care about you. I trust you. Let's keep getting through this time together. Let's keep learning. And let's keep believing in ourselves. Remember, one small habit a day can make a big impact on your future and on your life. I'll see you next time.
So we're going to start the Monet Bridge lesson. We're going to get our paper and write our first name, last name, room and grade. Flip it to the front, and then you're going to need to get your oil pastels. So you want some greens, maybe 2 or 3, to work on starting the bridge to go across. So I'm going to start with a curved line up, and then another curved line that follows that line, and then I can start working on some of the vertical lines that go across the bridge, like so. Then you want to take in that other color, and you can kind of go over that and make the lines a little thicker. It also adds a little more interesting colors if you use more than one, and you can kind of blend these together. You can see I'm blending the first one with the second green, and then I'm going to go back with that first one and blend again a little bit so that I have those blending together a little more. So again, making the bridge lines a little thicker. And then I'm going to go in with a third one that's a little darker, and I'm going to kind of put a shadow on the bottom of the bridge here, so it kind of looks like a 7, and then down this side. So the bottom of this spot and down the side. So that darker green will make it look like there's a bit of a shadow on the bridge there. So all the way across the top, and then down the right side of this shape. And then I might go back with a lighter green just on some of these spots here. Okay, so the bridge is pretty much finished now. The next step is you're going to be doing some lily pads in the water. So your water is all this space in here. So the lily pads can be any color, or the lilies I should say. I'm going to draw some lily pads. So near the bottom of the page they should be bigger, and then as you get to the middle they should be sort of medium sized, and then at the back of the paper or the top they start to get smaller. So this creates depth. So big at the bottom, medium size in the middle, small at the back. And then I'm going to add a little bit of that coloring with that oil pastel. This is a pretty quick part of the assignment. I'm going to blend a little bit more color with those. The ones down here at the front also are more detailed than the ones near the middle and back because they're closer to the viewer. So as I'm blending these together, and then I'm going to finish those out. So each one gets blended. It should look like oil pastel, not crayon. And we do that by blending the colors. I'm going to put some lilies on those. So those are the little flowers that sort of grow up off of that lily pad. So again, you can use any colors you want for this. I'm going to use a little bit of this color, and then as well as adding in some pink to that. And then I'll add in another color, maybe some orange here. So I'm moving the color around, so I don't want them all the same. And then maybe a little bit of yellow with that orange. And that is the first step. So if you just want to check this with the teacher, if it's finished, we're just going to store that in our art folder, and we're going to learn how to do the painting part next class. So the next step is to go over to the counter for painting, and we are going to dip our brush in just a plain water, and I want you to put the water all over your paper. So it's just plain water, a light layer. You're getting the paper a little bit wet, and then we're going to be painting some watercolor on that. This is called a wet on wet technique. So next what we're going to do, that's okay, a little bit that gets smeared. So the next step is to use the turquoise paint, and it does say turquoise on it, and you're going to paint some spots of turquoise. This is your water, so just some spots of turquoise where you would like that. And then we're going to move on to the blue. Then we're going to put some blue in some spaces. So putting this in some of your other spaces, this is again still the water. We are going to leave the top and the bottom white paper for now. So I have a lot over here, so I'm just going to keep spreading this blue around since I had a little bit too much. But I'm going to again leave the bottom is going to be more just white for now. So I'm still using this blue to fill up some of my water spaces. And when you have about that all covered, so the water is covered with the blue and turquoise, then we're going to move on to the last color of paint, making sure all my lilies are in water here. Then I'm going to go to the last color, which is the green, and I'm going to be putting that on these top edges. So filling up the rest of that white on the top and bottom with the green watercolor. So spread out any puddles you have. And then the painting is finished. Then we're going to take this green watercolor marker and just draw some blades of grass down in this spot. Yes, it's wet, but that's okay. It will diffuse the lines. So just draw some grass in this space. And then the last step is you're going to just get a little pinch of salt and sprinkle this on your painting. It works when it's wet, so it has to be wet. This is why we're painting fairly quickly, so that when the salt goes on, it will pull up some of that color. And then the last step is to take this whole tray and put it on the drying rack.
Hello, I am Courtney from Mission to Move, and I am here to bring you guys some movement and mindfulness. We are going to have an 80s themed workout today. But first, before we get started with that workout, we are going to do our neural drills first. So we're going to start with our ankle tilt. So I want you to put one foot in front of you, and you're going to take that foot and you're going to tilt it on its side, and then you're going to step on it. Tilt it on the side and step on it. Tilt it on the side and step on it. Very nice. Let's switch feet. Put that other foot in front. We're going to do 3 ankle tilts on this foot. Ready? 1, 2, 3. Very good. Now I want you to put those feet together, find those knees, and we're going to circle our knees around, and then we're going to straighten them. Circle and straighten. Circle and straighten. Very nice. Now we're going to go the other direction. Reverse. 1, 2, 3. Very nice. Stand up nice and tall, straighten those legs and step them apart just a little bit. We're gonna do some hip circles. You're gonna push those hips around, but keep those legs really straight. Nice job. Let's do one more hip circle this way. Very good. And freeze. Now we have to go the other direction. Let's reverse. 1, 2, and 3. Very good. Let's do some mummy arms next. I want you to stretch those arms out as long as you can, and you're going to bring them all the way up and all the way down. All the way up and all the way down. Very good. Let's do one more set. All the way up and all the way down. Very nice. Now, thumbs up, arms out. We're going to pretend like we have marshmallows on our thumbs, and we're going to stretch those arms out and pretend like we're feeding ourselves those marshmallows. Very nice. Really stretch those arms out as long as you can. Awesome. Now we're going to reverse. So we're going to take the marshmallows out of our mouth. Very good. Stretch those arms as long as you can. Who has the longest marshmallow arms? Very good. And shake it out. All right, kiddos, are we ready for this 80s workout? Let me get some 80s tunes on. All right, we're ready to go. We're gonna nod our head yes first. Ready? Look up, down. Keep those necks really long. Now shake your head no. And through the shoulder. And big circle. Other way. Now circle your shoulders backwards. And forwards. And shrug those shoulders up and down. Up and down. Up, down, up. Faster. Good job. Now we're going to do one shoulder at a time. One, and switch. Are you ready to go faster? Nice job. Now find those hips. We're going to shake those hips back and forth. Very good. Now twist. Make sure you keep your feet and your knees and your hips where they are, and just twist your arms and your shoulders and your head. Nice. Now arms out like an airplane. We're gonna go side to side. Very good. Now you're gonna take one arm we're reaching and grabbing stars out of the sky. Are you ready? Reach and reach. Reach, let's go faster. Nice job. All right, we're gonna keep reaching, but this time we're gonna reach to the side. And twist, and reach, and twist. Nice job, now we're reaching over heads, like this. All right, we're gonna go faster, are you ready? And faster. Very good. All right, now I wanna see those muscles. Squeeze those muscles. Squeeze and squeeze. Nice job, other way. You guys are doing great. All right, let's practice the star jumps. Remember, for star jumps, we jump out to a star and then we jump into a popsicle. We do a star and then a popsicle. Star and popsicle. Are you ready to go faster? Let's go. Nice star jumps. Very good. All right, now put your arms out like this. Show off those muscles. And you're going to pick up your knee and you're going to put it down. So you have to use those muscles and you have to balance. Nice job. Pick it up. Put it down. Can we try it faster? And down. Up and down. Up and down. Nice job. Keep it going. Very good. Now let's try the other side. So switch to the side. Remember, you pick it up and then you put it down. Pick up that knee. Put it down. Pick up that knee. Are we ready to try faster? All right, faster. Nice job. And run in place. Okay, we are going to run in place even faster. And 5, 6, 7, 8. And 3, 2, 1. Freeze. Nice job. Let's do it again. And run as fast as you can. Faster, faster. 3, 2, 1. Freeze. One more time and run. And 3, 2, 1. And freeze. Nice job. Arms up and happy feet. And bring those arms down. And up. And down. Up. And go in a circle. Very good. Now, we're going to take a big breath in. Big breath in. And let it out. Big breath in. And let out that air. One more time. Really fill up those lungs with air. And let it out. Nice job. You guys did awesome with your 80s workout. Real quick, before I let you go, we are going to do our hand breathing because remember, we can control how we feel using our breath. So we're going to take a big breath in and out. Big breath in and out. Very good. Remember, our breathing exercises are in a race. In order for your breathing to help you, you have to go slow and take really big, deep breaths. Nice job, friends. Give yourself a pat on the back, kiss your brain, and give yourself a big hug and throw your hug and share it with all of your friends and family. And you guys have an awesome day. Thanks for exercising with me.
Live and totally not pre-recorded, this is Math Class Live with Mr. D. Hey, today we're going to be talking about relationships between quantities, and what I want you to do right now is I want you to grab something to write with, and I want you to grab something to write on, because I want you to follow along with us for the next 20 minutes, and I think it's going to be really, really helpful. While you get something, I'm going to explain to you what we're going to do and what I expect you're going to learn with this lesson, okay? All right. So what we're learning today, today we're going to try to solve some new kinds of problems. And up until now, we may have been dealing with ratios or constant proportionality. These are slightly more advanced problems that you're going to get in 8th grade and high school. And so I think this will be really exciting. But I think it's going to be really straightforward for a lot of people that that understand ratios and constant proportionality and stuff like that. What you should know by the end of this lesson is you should have another strategy to solve some more complicated word problems, right? So the types of problems that we're talking about, constant proportionality, ratio, those are pretty simple and straightforward, right? We're going to add another layer to this, and I'm excited to see how you deal with it. All right, so let's get to the first problem. So the first problem is pricing theater popcorn. So a movie theater sells popcorn in bags of different sizes. The table shows the volume of popcorn and the price of the bag. We want to complete the first column of the table with prices where popcorn is priced at a constant rate. That is, the amount of popcorn is proportional to the price of the bag. Now let's write down what proportional means, right? So proportional means times a constant rate. Okay, whether it's a ratio or constant proportionality, that's what we're talking about when we're talking about proportionality. All right. Then in the other column, we want realistic example prices where the amount of popcorn and the price of popcorn are not in proportion. Okay. So what I want you to do right now is I want you to take a look at column 1, and let's just do column 1. Let's look at the price of the bag, and let's figure this out proportionally. And I'll give you a couple of seconds to do that now. How you doing? All right, let's take a look at this. So remember, proportionality means that we have to be multiplying times a constant rate, okay? And so the example that we have, so the information that we have, the most complete information that we have 10 ounces of popcorn, and it costs $6 for 10 ounces of popcorn, all right? And so what's going to be really, really helpful to us, I think, is to be able to multiply times how much it would cost for 1 ounce. And so let's figure out how much would it cost for 1 ounce. So if 10 ounces cost $6, so that'd be $6 per 10 ounces, right? The output divided by the input. That's what we do constant proportionality. If you're an older student, you know this as slope. Okay, so $6 per 10 ounces means that they are charging us 60 cents per ounce for 1 ounce, right? Okay, so that is our constant. That is our proportional constant, right? And so 10 times 0.60 is going to be equal to $6, right? And we are going to multiply 20 times 60 cents, right? So to find out how much does it cost for popcorn that's 20 ounces, and when we do that, we get an answer of 12, okay? And then for 35 ounces, we're going to multiply times 0.60, right? And we should get $21. Now we're getting into some very, 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 very pricey popcorn, all right? And then we're going to multiply 48 times 60 cents, okay? And this is going to be $28.80. One of the nice things being a middle schooler or a high schooler is you get to use a calculator. And I'm not going to lie to you, I have a calculator right there. All right. So $6, $12, $21, $28.80, right? These are the prices of popcorn if it is priced proportionally. That is, if it's priced at 60 cents per ounce. Now let's think about the movie theater or something like that where they don't price things proportionally. So a bag that starts at $6, you might get a discount for getting twice as much. So maybe you're paying $11, and you might I don't know, they might get another discount. So maybe instead of $21, you're paying $16 because you're getting a lot of popcorn. Maybe you get extra refills too, but we're not even going to go there. All right, and then maybe to get the jumbo, you pay $18.75 or something like that. So it's just it's a pricing structure that doesn't we're looking for a pricing structure that's not proportional, that maybe has some rationale behind it, but we can't mathematically express it very easily. All right, let me give you one more example from our graphics department. So our graphics department put together a third example where the bag of popcorn cost $4 each. And then there was proportionality, but we had proportionality at 20 cents per ounce. Okay, and when you price the bag at $4 each, and then you have this proportional relationship between the popcorn and the cost being 20 cents per, this is what the pricing structure would be. And we're going to get to a similar problem like that, but I wanted to just flash that at you really quickly and get that in your head that sometimes it may not look like we've got a relationship, but we can actually vet out a relationship between the ounces and the cost by adding that constant. In this case, the cost of the bag. All right. So moving on. All right, so the second activity we're going to do is called entrance fees, and here's how it goes. A state park charges an entrance fee based on the number of people in a vehicle. A car containing 2 people is charged $14, a car containing 4 people is charged $20, and a van containing 8 people is charged $32. How much do you think a bus containing 30 people would be charged? I want you to think about that, and while you think about that, I'm going to write some stuff on our table that I think is going to be helpful for us. So do that right now. I'm going to write. We'll come back and we'll talk. All right? Okay. How you doing? All right. So I don't know what you got for an answer, right? And you can't talk to me over the internet or whatever. So what I want to do is I want to just kind of point out something to you, because there is a proportional relationship here that we can vet out, and I want to show you how. So when I take a look at the information they gave us, there are differences between 2 and 4 people and between 4 and 8 people, right? So when we changed from 2 to 4 people, we paid $6 extra. So $6 for 2 people. If you try to figure that proportional relationship out, we get $3 per person. Okay, and then for the second one, when we got $20, it goes to $32 when we add 4 more people, right? And so $20 for 4 people is equal to $3 per person. Well, that's interesting, right? And so this kind of goes back to that example that I was showing you before. So we do have this proportional relationship. We call this a slope in high school and 8th grade. But we need to come up with another explanation for the difference between just a straight proportional relationship and, so how come I'm not paying $3 per person? How come I'm paying a little bit more? And in this case, we're going to assume that it's the car, right? So let's let C equal the car fee, because we know that people pay $3 to get in, right? And so let's try to figure out what the car fee is. So when I have 2 people that come in and they pay $3 each, so 2 times 3, they also pay a car fee and they end up paying $14, right? Well, 2 times 3 is equal to 6. 6 plus the car fee is equal to $14. And so we got to think, what number can I add to 6 in order to make 14? Do you know it? Well, if you don't know it off the top of your head, one thing you can do is you can use equality properties in order to solve this problem. And what equality properties are, just to remind you, is they're operations that I do to both sides of an equal sign in order to keep both sides of an equality equal. In this case, I'm going to use the opposite of plus 6. I'm going to do minus 6. And on this side, I'm going to do minus 6. Well, plus 6 minus 6 is equal to 0, so that will cancel out. And so I think the car fee is $8. But what I'm going to do is I'm going to check my work. I'm going to say, is 6 plus 8, right? So 2 times 3 plus 8 equal to 14. It is, and so I'm going to assume that the car fee is actually $8. Okay? So going back to this problem of 30, now I've got a relationship that I can kind of build on. So 30 people, and they are going to be charged $3 each. So that's $90 plus an $8 car fee is equal to the total price. And let's just say that's T. Right, and let me write that down someplace. I always like to name my variables. Okay, oops. Okay, and so 90 plus 8 is equal to T. T is equal to 98, and we'll put that over here in the table. All right. So now I think we're cooking with oil, right? So we've got an identified price for cars. We know exactly how much people cost, but now they're throwing us a curveball. They're saying if the bus is charged $122, so instead of an input, if I give you an output, how many people do you think that it contains? Well, oh wow, mind blown, right? So what we're gonna do is we're gonna use that setup that we had, right? So $3 per person. But P is going to be equal to people. I'm going to identify my variable there. 3 times P, people, plus the cost per car. So even though it's a bus, we're going to assume it's only $8, is equal to the total price. That's $122. Okay, so we can use equality properties to do this as well. And what we would do is we would, I didn't put that in the best place, did I? Well, let's do. All right. So what we can do, the opposite of plus 8 is going to be minus 8. I'm going to subtract 8 from both sides of this equal sign, and that will cancel out. I get $3 per person is equal to $114, right? And all I did is I just took the car fee out of both sides, right? They didn't pay the car fee, and we didn't charge them for the car fee. So the car fee is gone. I'm going to go away for a second, and I'm back. All right, and then the opposite of times 3 is going to be divided by 3. Divided by 3. Okay, so times 3 divided by 3, 3 divided by 3 is equal to 1, so that will cancel out. And P will be equal to 114 divided by 3, which is 38. Okay, and so the input here would be 38 people to pay $122. Now, what rule do we think the state park uses to decide the entrance fee for a vehicle? Well, I think $3 per person and $8 per car, right? And isn't that what we said? Isn't that what we figured out when we took these when we took the differences here and we found out that that every additional person that was being added to these different prices was paying $3 each? Yeah, okay, $3 per person, $8 per car. Right, and so that's kind of a twist on your constant proportionality problem, right? And it's a cool one too. It's a really cool transition into high school. So if you got this, you're ready for high school. You're ready to rock it, man. And we are going to go on to we're going to take a look at what our graphics department put together. All right. So here's what our graphics department put together. More or less what we did as well. We got a little equation here: S equals 3P plus 8. That's similar to what we had. So I'm going to skip this question here, for the sake of time. Okay, so here's a question. I think this is a cool one. So if you're solving at home, what I want you to do is I just want you to kind of write down some ideas here. If you are online, I want you to text me some ideas. I'm happy to share it online. So what are some different ways that we can mathematically represent the rule for this problem? So mathematically, right? And we said S is equal to state park fee. We may not have said that, but that's what we say. And then P is equal to people. Okay, and so we started, I think in that last slide, we said the state park fee is equal to $3 per person plus an $8 fee for cars, right? What are some other ways that we could represent this? Well, let's see. Well, we saw this in the last example. We said if we take away $8, right, from both sides, right, we get, so the total, so S minus A, 3P plus 8 minus A is equal to 0. So this would be a relationship 2 where I took the car fee away from the total fee, and it just gives me how much I paid per person. If I wanted to calculate how much I paid, how many people I had, I could divide each side by 3. Divide each side by 3, and I would get the number of people is equal to the state park fee minus the car fee divided by $3 per person. Yeah. So, I mean, there are all kinds of cool things that you can do. I think far more than the time that we have allotted. And I see a lot of people texted in, so I really want to thank Rob from the West End. I want to thank Maheja from the West End. I want to thank Jazz from Price Hill and Antoine from Price Hill for your answers. But at the sake of time, we're just going to keep rolling, though. Okay. All right. Making toast. So this next activity is kind of cool, and it's a different idea altogether. So a toaster has 4 slots for bread. Once the toaster is warmed up, it takes 35 seconds to make 4 slices of toast. It takes 70 seconds to make 8 slices of toast and 105 seconds to make 12 slices. How long do you think it will take to make 20 slices? Let's just do that one right now. I want you to do that. I'm going to do some drawing on this table real quick, and hopefully that's going to elucidate some things for you. But I want you to just do the thinking. Try to come up with a how long it will take to make 20 slices. Go ahead. I'm just going to draw here. That's cool. Okay, and so you may be taking a look at what I'm doing right now, right? And what I did come up with an answer for 20. It was 175. Okay, 175 seconds. And the reason for this, and if you take a look at my table, so every 4 slices, so I can put up to 4 slices in a toaster, right? So every 4 slices takes 35 seconds, right? And so I've got this other 4, and that's going to take another 35 seconds. I got another 4. That's going to take another 35 seconds. I've got another 4, another 35 seconds, another 4. It's going to take another 35 seconds. Okay? So the trick of this is just to realize that whether you're toasting 1 or 4 slices, it's going to take you 35 seconds. All right? And so we can if we're trying to make 20 slices, we can toast 4 at a time, 5 different times, and that's going to take us 175 seconds. Second question, so I want you to think about this, and I'm going to do a little bit more drawing, okay? If someone makes as many slices of toast as possible in 4 minutes and 40 seconds, and I want you to think back to what we did. So here they're not giving us an input, are they? They're giving us an output, okay? An output of 4 minutes and 40 seconds. How many slices do you think that they can make? All right, well, the first thing that we need to do is we need to convert minutes into seconds, right? So 4 minutes times 60 seconds in 1 minute. Or per 1 minute, right? The minutes cancel out, right? And 4 times 60 is equal to 240 seconds, okay? Then I'm going to add on this. That was just the 4 minutes part. I'm going to add on another 40 seconds, and I'm trying to find out how many pieces of toast can be toasted in 280 seconds. All right, I'm going to do a little more drawing. I want you to think in your head. I want you to try to do the calculation, see if you can come up with an answer. Go. Oops. So I got to 32 seconds and I see that, or I'm sorry, I got to 280 seconds and I saw that I got to 32 pieces of toast, right? So that's what I was trying to find. That was my goal. My output was 280 seconds. And so at 280 seconds, I made, or I could make 32 slices of toast. Oops. Wow, that's weird. All right, slice of toast. Okay, weird stuff happens on live TV, right? All right, we're gonna keep cooking. Hopefully you saw it, but that's kind of a whole different thing, huh? So, question: what strategies did you use to solve these problems? All right, so let me open that up. Why don't you think about what strategy did you use, and let's see what some people say. All right, I'm looking. All right, cool. I got a I got a text from Rob in the West End, and Rob said that he appreciated using the table, right? So the table was helpful for him. Good. I got a note from Alana in the West End. Okay, and what Alana says is she used Desmos. She used the Desmos calculator. Okay, well that's probably more advanced than I can get on the screen at the time, but Desmos calculator is a great tool that you're going to use. I assume that Alana is probably a 9th or 10th grader or something like that. So Desmos is going to be an awesome tool that you're going to use in high school, and definitely think that that's helpful. I'm really curious to know how you did that though. All right, I got a note from Cron, good, from Lachlan. Shout out to Lachlan, more or less saying the same thing as Rob. So good strategy, and these are things that we need to pay attention to, right? A table was really, really helpful. I think it'd be cool to see that, graph that Alana was talking about. But yeah, pretty awesome stuff. All right, we're gonna skip through some of this because we're out of time, but we might answer one more question. All right, so what made these situations more difficult than relationships that we've seen in the past? Well, let's take a look at that. All right, they aren't proportional, right? So these aren't purely proportional relationships that we've been dealing with, right? So we may have something else that we're adding, right? That is what happens when we go on in math, right? We do more sophisticated problems, and if you track this, which I think you did, I think you tracked it, right? You're rocking, man. And so now you're solving something that's not so simple as a proportional problem. There were situations that added a twist, like the 4 pieces of toast. I thought that was really, really cool, and hopefully that made some sense to you how we did that. And then there were rules that were more complex or tricky, right? And so there's sometimes people are going to throw you curveballs. It's not all going to be easy, but persist through it. There are people that can show you. You can always come back to live math class anytime you want to, and we can maybe we can watch it. Maybe we could make this not live. I don't know. All right. So anyhow, we are going to fast forward because we're out of time. Okay. All music used is licensed under a Creative Commons license. These are the songs, and we want to thank all of the students for your hard work during distance learning. We appreciate your efforts. On behalf of every teacher that you have, I have absolutely no doubt that every single one of us would like to be in the classroom with you and not with you on live math class. But in the meanwhile, when you got to stay home, please come back to live math class early and often. Thank you very much. See you again.
Okay, we're going to start with your first and last name on the back, your room number, and your grade level. And then flip it to the front. You can choose to turn your paper vertical or you can turn it horizontal. That is up to you. So I'm going to go vertical, and then we would draw a line here for the table and the wall. Now it's time to paint. So we are going to put a placemat underneath our painting paper. And then you'll get your paints at your table. You'll have your paint brushes, and you're going to start with your first color. And I'm going to bring this into view so that you can see I've got orange and purple. Those are the 2 colors I'm going to paint with. And I'm going to start with one brush, dip it, and make sure it's not dripping. If it is drippy, you can wipe it on the edge, but you probably won't even need to wipe it. And then what I'd like you to do is decide if the table's purple or the wall's purple or whatever color it is you're choosing. You're going to paint along that pencil line first. Get more when you run out. And then go ahead and paint the rest of the bottom space in that particular color. I'm going to go with a little bit bigger brush. You can use the big brush to start. Now you can see I'm using big strokes because it will go quickly, as well as you don't want any globs, because it helps it dry quicker also. Alright, so when I'm finished with that one, when you are going to do a new color, you need to get a clean paintbrush. So I'm going to switch paintbrushes and color so that I'm not mixing the purple in with the orange. I am then going to paint almost up to that line. I'm going to wait and leave a little bit of space so that I'm not painting into the wet purple. Again, nice big strokes. Fill up that space quickly. And the placemat obviously is here so that you're not getting paint on the table. And you can see I'm putting my hand in an empty white space until I get closer to finishing, as to hold my paper still. Now I'm kind of running out of space now, but I'm going to go ahead and go up to this purple, trying not to mix it. I don't want them really mixing. When you run out of paint, go ahead and get more on your brush. And then I'm going to get this last little spot over here that I was holding my finger on. And now my paper is completely painted, the wall and the table. So I'm going to walk this to the drying rack. Next, what you're going to do while you're waiting for your painting to dry is get a teacup and a saucer stencil. So you're going to put these both on the piece of paper that's been provided for you. So you have to put them both on together to make sure they fit. Hold it nice and still while you trace. You want to do both. Remember to hold it still and go all the way around, and don't forget this little hole, and that's where the handle of this teacup saucer is. And you can see on here that this is where the opening of the cup would go, so if you want to put that in there because you might want that for later, go ahead and draw that in there. Alright, next what you're going to do is make sure your name and room number and grade are on there. And using crayon, you're going to go ahead and start putting some patterns inside your teacup and your saucer. We are using crayons because we are putting a nice heavy thick layer of that that waxy color. So when we talk about patterns, get creative and add in different kinds of lines or shapes. They can be lines or shapes you know, or they can be lines or shapes you have seen around and made up to use. So I would say a few colors is enough. And we want to try to cover most of the white. So this color looks very similar to my lines. I should have picked a different color, but that's okay. Now inside the cup, you're going to want to put your hot cocoa. So if my cocoa is inside here, I'm going to draw that oval and then I'm going to color it in nice and dark so that I can finish the patterns around the cocoa. Okay, and then if you want to add a different pattern, you can go and add some different patterns to this. It's okay if you go outside of your pencil lines because we are going to be cutting these out. So you can do some coloring mixed in with your patterns. Again, we do want to fill most of the white. And then come check this with the teacher. If it's ready, we're going to go ahead and cut it out with our scissors.
All right, I think I'm going to call my friend Farmer Susie and see if we can come over and do a visit to her barn, because she lives on a farm. So let's see if we can go give Farmer Susie a visit. Hi, Farmer Susie, it's your neighbor. I was wondering if my friends and I could come over and take a look at your barn and kind of see what you have in there. Would that be okay? Great, thank you so much. We'll be over in a little while. Bye-bye. Farmer Susie said we can come over, so let's head on over to the farm. Good morning, boys and girls, and we are here with Farm Mom. She has let us come over to her farm, and I'm looking around right now, and I see goats, I see cat. And Farm Mom, what is this animal right in front of us here?
Okay, that is a helmeted guinea fowl, and he is a bird that originated in Africa, and so they are domesticated now, and these birds are supposed to be very good with foraging, and they say that they eat a whole bunch of ticks.
What's foraging?
Foraging is going through, do you see how he pecks all the time?
Mm-hmm.
He's always foraging for his food.
Right. And do they fly?
The guinea fowl does have the ability to fly more than chickens. They don't fly too far away, but they can fly from the house and the barn.
So who are these friends who are coming to join us now?
Those are our goats. That goat's name is, it was originally Grover because from the book, The Lightning Thief, he has a friend, his name is Grover, but he became such a bad boy about getting out and he jumped over everything. His name is Jumper.
Jumper? Nice to meet you, Jumper. Look at all these other friends coming to get Jumper, the one that wants to be around people the most, because he came right up to us.
Right, he's a little more curious, and he way more food motivated. I think he's the head of the crew.
Okay.
This one over here, her name is Sugar.
Hi,
And,
Sugar.
she is a boar goat, so my daughter and my son showed her at the fair.
Oh, wow.
And she's way more tame
Yeah.
because we showed her at the fair.
Right. So she's used to people.
Yes.
And you
yes.
wouldn't normally go up to animals you don't know, and yeah, we always have to be careful around new animals.
Right.
I see a big barn back there.
Yes.
Mom, what's it? Do you have anything in the barn?
Yes, we have animals in the barn.
Oh, can we go take a look at them?
Yes.
Oh my goodness. Oh, I hear some great noises. It's kind of dark in here.
Yes, let me get the light.
Oh, you have lights in your barn. Huh?
Yes. We have electricity.
All right.
Okay.
Look at that.
That is a rooster.
He's walking very proud.
Yes, my daughter named him Ember.
Ember.
And if you get to him, get close enough to him, you can see because of his color. Okay, well, yeah.
Oh my goodness.
So these are roosters.
He runs very fast.
Yes. So, these are chickens. The two smaller ones with the smaller headpiece are what we call the crest on their head. The two smaller ones, those are hens, and then the bigger one is a rooster.
Farmer Susie?
Yes.
Or Farmer? What is this down here? Is that eggs from a chicken?
Yes, the chickens are laying eggs.
Oh my goodness. Could we have an egg to see if we could cook it?
Oh my goodness, that would be fantastic.
Oh, that would be great. I'm gonna just, is it okay if I just reach in and grab
Yep.
one?
We need to actually collect the eggs, so why don't you get the rest of them for
Okay.
us?
One,
Because our dogs, they will
Two.
get them, and they will eat them too.
3. Oh, look at these pretty feathers. Pretty feathers.
That's from a guinea.
But these aren't guinea eggs.
No.
No, so these, okay.
There's just feathers everywhere.
So where do the chickens always lay their eggs in the same spot?
The
or-
chickens pick their own spot that they want to lay their eggs. I have made nests for them, and they will just go wherever they want to, because I'll make nests, and they won't lay any eggs. They go where they feel comfortable.
So now I know out behind your farmhouse you have a chicken coop.
Yes.
Why are the chickens in here?
Okay, so we had, here, I can open it up.
Oh, and there's some other things that don't look like chickens in there
Right,
too.
those are ducks.
Ducks. Oh my goodness. Do the chickens and ducks? Oh, I'm sorry. Do the chickens and ducks get along?
Yes.
Okay.
They're, and I'll explain. Those are the male ducks, and they are in with the females. they aren't in with the females because the boy ducks like to bug the girl ducks.
Oh no.
So we are trying to keep them separate. But the reason we have these chickens in chickens from eggs, and we couldn't put them in with the mature chickens, so we left them out in the barn to mature out in the barn. And we had the ducks and we had the other guineas in the barn.
So once they get a little bit older, will they go out?
Yes.
And they'll be able to roam around?
Yes, we'll be able to free range where they can get all the bugs and everything.
So chickens eat bugs?
Oh yes, they eat lots of bugs and worms. One of the treats that I give them are actually dried worms. And they come running when they know I'm coming out of the house.
Do you have any dried worms out here?
No, they're up at the house.
Okay. Well, this is fantastic. Now, I think outside the barn, I saw a pony.
Okay, let me see if I can...
Oh, I think I heard something.
He knows. Okay, so in here, this one, there are also... Oh, the duck, she's in her nest. Ducks leg eggs, too.
Do you think that we could see if a duck egg is the same as a chicken egg?
Sure, once she gets off her nest. So you'll notice in here we have more guinea. So there's, even though they're white, they're still called the helmeted guinea fowl. And they're very noisy. And then those two ducks are the female ducks. And they lay eggs. So while we're leaving her on the nest to do her business, lay an egg hopefully, we'll go over here and look at the pony. Hey Skittles. So the pony's name is Skittles. Does anybody like the candy? It's like Skittles. Skittles.
Do you like Skittles? How old is Skittles? Do you know?
Okay, so we don't know how old Skittles is. He could be 15 to 20 years old.
Oh my goodness.
So let me go in here and see if I can chase off the goat. You guys take a look there. I'm gonna get my thing to chase him away.
What are you doing? The goat doesn't belong in there, does he?
Oh, they're friends.
Goat, are you trying to eat Skittles' food? Hmm? How are you doing, Skittles? Yeah. Yes, look how big you are. Yes. Oh, and here comes a rooster up behind. And a guinea. Wow, look at all the animals here on the farm. Oh, here's
some
farm
feed.
life. Oh.
And so, you know how the duck or the goat is in with the pony? Mm-hmm. They know that the pony gets fed, and they want to eat the pony's feed.
Oh, no.
So I need to chase them away.
Uh-oh.
Because they're kind of pushy, and they push the pony out of the way.
I think the goat needs to go to timeout.
Yeah. So I'm going to try and do.
Oh.
And they ate the shepherd's hook.
Oh. Well, so she's closing the back door to keep the goat away, but if the goat wanted, could he jump over that door?
We don't have goats that jump over the gate.
Okay.
The pony knows he can push it over.
Oh, okay.
So we'll put, he knows something's up. So go ahead and pour the feed into this bucket.
And look at the goat on top of the bales of hay out back.
Yes. They don't care how they eat their food.
Oh.
Very nice.
I heard a rooster crow.
I did. And I see a goat back there on top of the hay eating, and a pony, and ducks and guineas. This has been a fantastic trip to the farm. And we've got eggs we're going to take back and try to eat and see if these are just like the eggs we buy at the store. Are these like the eggs we buy at the store?
Yes, they are.
Outstanding.
But why are the eggs at the store white?
Well, the eggs at the store come from a different breed of chicken. Typically, the eggs at the store come from, I believe it's a white chicken that lays a lot of the eggs. And so our chickens lay gray, or the brown eggs, and we've also had chickens who lay green eggs.
Oh my goodness.
Green eggs.
Like green eggs and ham?
Yeah.
Sure, but when you crack it, it looks the same on the inside.
Oh, the same. Oh, the inside. So this will be the same on the inside as a white egg.
Yes.
Okay.
Yes.
Well, thank you. All right. Well, thank you so much for letting us come visit your farm, Farm Mom, and we appreciate the eggs, and I can't wait to go give them a taste.
Yes. She's off her nest now. Come and take a look at what's inside. The big eggs are the duck eggs. And what's funny is our hens, they've decided that this is a nest that they want to lay in too. And so here is some brown eggs. Here's the difference. A duck egg and a chicken hen egg. Isn't that funny?
Which one is bigger? Looks like the duck egg is a lot bigger than the chicken egg.
I think so. These ducks are called Crested Ducks, and they're called Crested Ducks because of their hairdo on top. Only these type of ducks have the funny hairdo on top. If you remember from earlier in the video, the other ducks that are out in our barn, they don't have this hairdo, so they're called crested. Also, over here, I talked about worms. Here's a great big bag of dried worms. They're not alive, they're dead, but they're dried. And the chickens and guineas and everybody just love them. It's like candy to them.
Sounds delicious.
Tasty.
Welcome back, boys and girls. We are back from the farm. Remember, we have our duck egg. We have our brown chicken egg. Farmer Mom gave us a green chicken egg. And here's just a regular old white egg from the store. So we are going to take a look at these, see how they look compared to each other, and then we're going to cook them up and see how they taste. So I am going to start, first I'd better wash my hands. Ooh, they smell lemony. I'll dry my hands. And now we will start with the white grocery store egg. I'm going to crack it on the side and open it up. Put the shell, that cracked really easy. So we've got kind of the clear part and then the yellow yolk. That's the middle part. Here's our green egg. And that cracked nice and easy. And I'm going to open it. And there's our green egg. Now that yolk might be a little bit darker, but it could also be the bowl. Here's our brand new brown chicken egg. And I'll crack that. Okay, we've got 3 eggs now. 1, 2, 3. So the white one, the green one, and the brown one. And this last one's our big duck egg. So let's try that. Ooh. That one I've got to hit a little bit harder. That one doesn't want to crack as easy. Oh my goodness. Look at that. Look how big the yolk is on that egg. Now we need to decide, how are we going to eat our eggs? I like mine scrambled. Does anybody else have a different preference on their eggs? Scrambled? Mrs. White, how do you like your eggs?
I like them over easy.
Over easy. You may be cooking your egg then, because that is not my strong suit. So which egg do you want to do over easy?
How about the green egg?
The green egg. So this one, We will save over easy, and then we will scramble these up. Okay. Now that's the white egg. Here's the brown egg. Ooh, look how, when you open up that yolk, look how dark that got compared to the other one. That farm egg is a lot darker yolk than the store-bought white egg. And here is our duck egg. Oh, that's a big yolk. And a lot of egg white too. So we'll just stir this one up. All right. We will cook these up and then we'll come back in a couple minutes when we do our taste test. All right, so we have gotten our eggs ready. We have cooked them up and now we're going to do our taste test. So our first egg, remember, is our white store-bought egg. So we're going to take a little taste of our white egg. Tastes very much like an egg.
It does.
It's very eggy. That's good. Okay, now our next egg, these are both farm eggs. So I did my brown egg scrambled.
And I did my green egg fried or over easy.
But yours certainly didn't turn out green, did it?
It did not. It is white with it's kind of an orange yolk in the middle.
Okay, so we'll try our...
If I can get a piece of mine.
I think this egg has more flavor to it than the white store-bought egg. And the color.
It does a little.
Mine, it's more yellow. The yolk was darker than the store-bought egg. So this is the fresh farm egg that the chickens just laid this morning. I'm going to have another bite of it. That's very good. Now, for the duck egg. This should be an experience. Not many people eat duck eggs.
We should show that both of these plates came from the same egg. And all of the other ones were just one egg as well. So I think this one made more.
Oh, you are absolutely right. There's probably twice as much egg using the duck egg. There's twice as much food that came out of it than the chicken eggs. That's a very good point.
Pretty good.
Pretty good. It's a little bit chewier. But if I didn't know it was a duck egg, I probably wouldn't notice the difference. Probably wouldn't notice the difference. But I also, and all the boys and girls know, I always have to have my bubbly. So, to get a little drink of my sparkling water. All right, well, thank you so much for joining us for our egg taste test straight from the farm, and we will be seeing you soon.
Okay, so our next step is we're going to be adding patterns to our wall and our table. So you want to pick some oil pastels that may be good contrasting colors to the ones you painted. So for example, in my orange, I'm going to do some blue. So you could start with some stripes and put some patterns inside. Or if you have other ideas. Remember, patterns are anything that repeat, lines or shapes, also colors. So that's why we will be repeating some of these colors. So we're going to work on filling up this space with some patterns. And I'm going to use 2 to 3 colors on the wall and 2 to 3 colors on the table. Now I'm going to move to the table section, and I'm going to do some lines, maybe going in a different direction. You don't have to do the lines, but it does help organize your pattern into a space. And then I'm going to start adding some patterns within those. When you feel like you have finished your wall and your table, come up and check it with the teacher if you feel like you have filled up that space so that we can see if you're ready to do the next step. So once you have cut out your saucer and your mug, we are going to be gluing these on here. So you want to lay them into a position where the saucer is on your table and the mug is touching the saucer at the bottom. So you want to look at that and see where it should go. So if I want that here, I'm going to flip this over and put glue on the edges and then stick that on my table, holding it down so it stays. Then I'm going to flip my mug over and put glue on the edges of that as well. Then we're going to place this like so and push that down. Make sure it's nice and flat and hold it while it sticks. Then we're going to take the black oil pastel and outline the edge of this mug and saucer. So this will help it stand out on the background that we've created. Don't forget the handle. So you can see I'm making a nice thick line all the way around. And we're going to even go around this rim of the cup. And then we're going to do the saucer as well. So again, the edge is what we're putting that black line on. And then if you would do your line between your wall and your table. And then last, if you'd like to add some steam to your hot chocolate, you can take that white and you can make some sort of wavy, swirly lines. And then we're going to turn that into the grating box when you are finished.
Hey, good morning, good afternoon, Data Culinary students. Coming to you today with our Buttermilk Assignment. If you look on Schoology, you can find that. Basically, it's talking about what can we use in our house if we didn't have buttermilk. Well, the simplest thing we could do is we could turn milk into buttermilk. Basically, it's a soured version, right? So we culture it a lot like we do sour cream and yogurt these days. But it's an essential component when we're making certain items to put that acid in there and make that help with the chemical leaveners that we do. And that was the other part of the Buttermilk Assignment, was to talk about chemical leaveners. And a chemical leavener is going to be something like baking soda or baking powder. Typically, those are going to be two things you're going to do to help give rise to your baked goods. So when you're baking a cake and that cake recipe calls for baking soda, maybe, it's also going to call for some sort of acid to help that sodium bicarbonate, which is an alkaline, create carbon dioxide and then in turn create that rise. So we look at what we have in our pantry and our kitchen to say, hey, I want to use that baking soda. And sometimes we use baking powder still with an extra acid involved in it. Now, all baking powder would be is we take that baking soda and we give it some acid to work. We help it along. So bakers like that baking powder because it already has baking soda in it. So it's going to have baking soda, cream of tartar, and typically cornstarch. Those are going to be the pieces. And over time, they lose reactivity. So can my baking soda go bad? Can my baking powder go bad? Absolutely. It doesn't spoil. but it loses some of that chemical reactivity, okay? So when the baking soda and the baking powder are mixed in there with all the liquids and the acid, they start making carbon dioxide, which is why you see little bubbles in your cake or your bread. That's that rising air bubbles that get trapped inside the glutens. So we have to make sure that we want to create that balance. Now, if you've ever had a cake that had too much baking soda or baking powder in it, it's going to taste kind of soapy. That's going to tell you that you didn't have enough acid inside of your mix to neutralize, to be neutralized by all of that, to kind of create a zero. So some things we can use for acid is buttermilk, sour cream, yogurt. We could use something like that. Non-dairy additions might be baking powder is going to be that, or a non-dairy milk turned into buttermilk. And it's going to be exactly the same way. So I'm going to do that first so it can sit while we talk about a couple other things about what we're going to do and the tools we're going to need. So right here I have 1 cup. I'm going to move my camera a little bit. You can see all the ingredients we're going to use today, but I'll move this back. So I have 1 cup of milk. That's just a 2% milk. You can use a whole milk, you can use skim milk. It's just going to create different levels of butter fat inside. And what I want is for my recipe here today that we're going to use is I need 2/3 cup of buttermilk. But what I'm going to need to turn that into buttermilk, and I'll show you here that I have just about a tablespoon. I squeezed 1 lemon. And so I have just about a tablespoon. And I'm going to put that lemon juice because that's going to give us flavor. You could use white vinegar. We could use cider vinegar. You could use lime juice. Just a vinegar. And what you're going to see is this is going to have a little reaction here in just a little bit. We're going to set this off to the side, and it's going to try to curdle itself up a little bit. All right, and so while that's working, I'm going to talk about a couple other things that we're doing here at home. Some more science that we're doing here at home that you could partake in, right? So my bakers out there from Baking and Pastry Arts and Contemporary Cuisine, we've made bread, we've done all that stuff, and we have dry active yeast at the shop, right? In the lab. So that dry active yeast is how we get, that's our leavener, right? That's our rise. That's what's giving us that rise, which is the baking powder. It's going to help give us our rise. Sometimes eggs help give you that rise, right? But what we're going to use at home here, because I didn't have a big bag of yeast like we had back in the lab, is I created my own sourdough. And all you need to make sourdough is flour, water, and salt. Now, whole wheat flour is the best flour to have. You can use the all-purpose flour, but you want to make sure that it says unbleached, okay? The bleached flour is going to take a lot longer to work, and it's just going to take a lot longer. But if you have an unbleached all-purpose flour like this right here, you can use it all day long. Semolina flour, whole wheat flour, high gluten flour, bread flour is really, really great for this. So what I basically is 1-to-1, all right? So I took 50 grams of flour and 50 grams of water, and I mixed those two together, and I put them in a jar, and I left them, right? And I left them. And you can see my rise here. Let me move my camera back down so you can see. So what happens is, and this sourdough is now a few weeks old. I started this the second week of quarantine. So I mix it together, and every day I mix a new 50 grams of flour and water together, and I take 50 grams of this starter, and I put it in there and I mix. And every day it starts right down here where you see this little block, and it rises up, and you can see it's risen. It's actually just a little bit taller than it is right now. It's starting to shrink. It means it's consumed all of the food. So what I've done is I've given a place for yeast to grow naturally in the air, in the wheat, off my skin when I touch the spoon. Wherever yeast lives, it gets down in here and it makes bread, turns into bread. So basically, in a few weeks, when I'm ready, even though this really is starting to, it smells delicious. It's sour bread. It smells like bread, like baked bread. I'm going to take this in a few more weeks. I'm going to let it keep growing. And I'm going to turn it into sourdough. And that'll be a thing we do, especially if we're stuck here for too much longer. We'll do that in parts, because that's a long staged process. It takes about 4 to 12 hours to proof. So what I'm seeing is a great double rise, one and a half, 2 times rise, getting all the way up there. Maybe 2.5 times rise is really, really what I'm looking for, so that when I use this to proof my bread is going to rise. It's going to leaven, right? And that's what in our cakes today that we're going to make, that's what this is going to be for. This is my baking powder, okay? So that's just a fun experiment. You can do that. You got to feed it. If you put it in the refrigerator, you can feed it once a week. That's that 1 to 1 to 1. I've been keeping this one. I got another one in the refrigerator, but I've been keeping this one out at room temperature. So I feed it about every 10 to 12 hours, depending on how it goes up and down. But it stays out. It's alive. It's living. It's super happy. It smells. It's like I'm baking bread. I can smell it through. I give it a little cloth. I don't have it in a tight-fitting lid so that it can rise. It can breathe. It's not being choked off. So that's super fun. That's something that we're working on here. You can do that at home. Juniors who are going into baking next year, I don't know if I'm throwing out a little suggestion here at you, but you might want to make one of those and just keep it alive all summer long if you can. Maybe show up in the beginning of school when you sourdough instead. I don't know if you can. Just saying. Another quick thing we've got here is our buttermilk is starting. It's hard to see on the camera, but I can see the curdling happening inside my milk here. So it's hard to see on the camera, but it is happening. There's a reaction going on. I can smell it. One other thing we started to do, a little more science. Here it is. I'm regrowing a celery from a celery stalk. I'm going to show my other camera here because I'm recording off of 2 places at once. But yeah, so here we go. We just been changing the water out about as much as it drinks, or every other day. And you can see you got some new celery growth right there. When this gets up a little bit, I'm going to put it in my garden, see where it goes. I'm doing the same thing with a couple of onions here, which have self-sprouted. They're going to go out into the garden here in a little bit. And you know what else I did? I had some potatoes that had taken to growing. So I planted them. And one of these days I'll jump on the phone and we'll do a live stream going outside and checking out the garden stuff. But the potatoes are taking off. I'm going to have purple potatoes. It's going to be great. Well, we'll see how purple they are, because, it does take altitude. All right. So we're going to make funnel cake today. Let me get rid of my coffee cup. We're going to make funnel cake today, and we're going to make powdered sugar, because you might not have powdered sugar at home. Not everybody does. You might not keep it on hand, but you may have a bag, a jug, a whatever of granulated sugar, all right? And that's going to turn into powdered sugar later on. Hopefully you have a way to do this. If you don't, then you'll probably have to get powdered sugar. All right. So things you're going to need. So off the bat, you're going to need your measuring cup, because you're going to need this to measure out your milk. To make your buttermilk, you're going to need this to measure out flour, okay? You're going to need measuring spoons, all right? We've used those up. You're going to need a mixing bowl. I've got funnels here, but we're going to talk about those in a little bit. A whisk and a spatula to help things along. A small bowl for mixing, okay? So we got our bowl here. We're going to put in 1 1/3 cup of sifted all-purpose flour, and I sifted that earlier, so hopefully it's still going to go some air in it. So the sifting, what does that do? That puts the air, helps put some air into our batter, right? So it's not all heavy. And in here, if you can see this, there's 2 different measurements in there, but I've got 3/4 teaspoon. Sorry, I've got 1/4 teaspoon of salt and 2 tablespoons of sugar. Okay, they're gonna go in with my flour here. All right, and I've got 3/4 teaspoon of baking powder. That's my chemical leavener. All right, I've got 1 egg, which I'm gonna crack. My little whisk here. Okay. Use this to set that on right there for a moment. Maybe not. Okay, so I'm looking at my measurements here. You can see I've got little dings in the side that I can see inside as well. and that'll take me to 2/3 of a cup. So I'm going to measure out. Line right there, 2/3. I can actually read it on the inside. And if you can't see that, it just put some curdled stuff down in there in the bottom. You'll see chunks are starting to come out and form, and that's what it's basically doing, is separating it all out. It's curdling that out a little bit. It's creating a culture in there. All right, so I beat my egg, right? And it's in here. I'm going to add my buttermilk to my egg. It's going to help me pour that out a little bit easier. So I'm going to add that right into there. 2/3 of a cup. I'll give it another little beat. Meanwhile, back at the ranch, we're going to move our camera around here real quick. So I have over here oil. And let's see what the temperature of this oil is. This oil is at 200 and nope, we're at 350 degrees. This is going great. All right, so that oil is going to be nice and hot. We're going to, because we want to move quickly. All right, so here we go. We have funnels. Normally, I would take my batter from here and I would use my funnel and I would pour it in a little bit at a time and funnel it around. Not everybody's going to have a funnel at home. Don't fret. Do you have sandwich baggies? Do you have plastic wrap? Well, sandwich baggie is going to be the best idea. You can make a funnel out of this. You're going to pour all your batter into this bag, okay? And then, so now you have basically a piping pastry bag, and we'll cut a little tip off, but we'll hold it upside down like this, and then we'll drizzle in, all right? Then we will pinch the corner of the bag off. We can add a little bit more to it, and it'll be a little easier to move around with. You can utilize something like this to help you. That way, if you lose some into the bottom, it's okay. Let's see. We've got tons of these here because we use them at home. All right, but we're gonna move fast because once you add liquid to our baking powder, let me grab that real quick. Oh, and that was the other thing. Whew, good thing Chef looked at that. Now I'm using double acting baking powder. So what basically that means is the baking powder has 2 acids in it. All right, has a first acid, the cream of tartar, which acts fast. So as soon as I put that liquid in there, it's going to start to go, right? And it's bubbling and it's making carbon dioxide. And then once it hits the heat, that second acid activates, and that boom hits that out again, and boom, it creates a second rise. So you'll have that first rise, but then once we put it in the hot oil, you'll see it poof out. That's the second rise. Or when your cake goes in the oven and it lifts up, that's the second rise. So remember that. Double acting baking powder has 2 acids in it. I don't know where that might show up, but something's going to ask you that. Okay, so here we go. So we're going to mix our liquids into our starches. Oh, yeah. That's going to make a batter, a sticky batter, kind of like a thick pancake batter. And you can make it a little runnier if you want. You can always add in a little extra milk to it if you needed to. Right, and say, hey, I wanted this to be a little thinner. I want to have my stuff a little thinner. That's completely fine. But what's happening now is our chemical reaction has begun. All right, our batter is mixed and our chemical reaction has begun. This should be pourable. So I'm feeling it's a little thick. You feel me? So I'm going to give it a little bit, just a touch, a couple tablespoons to get me to the right consistency, because this should be a pourable batter, okay? Oh, yeah, look at that. All right, so let's go over to the stove. All right, and I'm going to rework. Let me get my hot holder here. I'm going to rework where this oil is so it's a little easier to see. Okay. It's going to get hot real fast, more hot than we really need. So we are going to, sorry my back is to you guys over here. I'm going to try to move this over here so you can kind of see what I'm doing. Whew. All right. So we've got our batter. We've got our bag. We've we've got our batter and we've got our bag. And I'm going to put my batter in my bag first, and that's going to go so I can bring it over here. So we'll turn this over here so you can see what I'm doing. Okay. And if it's easier, I'm just pouring in some of my batter into my bag. There's a natural stop. I think this should make about 4 funnel cakes. So if you're wondering about that, this should make about 4 funnel cakes. I'm going to zip up all but a little bit of my bag here. I'm going to cut off my edge. I'm going to show you both with the funnel and without. So you see here, cut the edge of my bag. And we're just going to go right around in a circle. Pushing that out into one cake. Check that out. So now you can see, let me get, you can see here that in the cake has expanded. It got a little fatter, right? And it's cooking up nicely. So it's right now, we're going to let that cook and get nice and golden brown. And while that's getting golden brown, we're going to take a little bit of sugar. So this has a nice little measurement on it for me here, so I can see that I have 8 ounces. So I'm just going to take about 8 ounces of sugar, about a cup of sugar in this little guy. All right. And put the lid on it. It's going to get loud. Oop, I see a nice golden brown happening. Let's flip our funnel cake while we do this. So I'm going to take it gently. I don't want to splash myself or others. Oh, look at that. Holy shnikey. Looks delicious. All right. Grab the grease. And a plate. We'll set that there for ourselves. Then basically what we're going to do here is, hi, wife. I'm running this sugar through a food processor. Because really that's all powdered sugar if you think about it. So you got a blender at home, you can do this with a blender. It's going to be easier if you put enough in so that it can move around. But what you have found here, let's see if you can see this. This sugar is kind of powderized. All right, watch what happens when we put it on our funnel cake. Oh, doggy, that looks delicious. All right. Nice crispy crust. So we'll take that here out of the fry oil and put it right there. So we got our funnel cake now. Smells good. And we're going to go ahead and put our powdered sugar on it there. You see that? You could top this with whatever. Cinnamon and sugar. Look at that. Bring it over here so you guys can see too. Very cool. So that, my friends, is using buttermilk as a substitute. I added it for flavor in my funnel cake. We want to remember that there is double acting baking powder, has 2 acids in it. So when you're filling out that assignment on Schoology, you're answering those questions. Remember that these are some of the key pieces. And then I'd love you, the other part of the assignment is to do your own change out. Make something with buttermilk that you created. Okay. Make sure you use a chemical leavener. So you're using baking powder or baking soda. Post the recipe to me. I'll make an assignment. I believe I already made an assignment in Schoology, so you can post that to me. Thanks for watching. I'm going to make a few more funnel cakes with fresh powdered sugar on them. and keep on cooking. I'm really enjoying this. And don't fret to experiment. If you want to mix stuff, you don't have to use egg. You can find recipes out there that don't use egg. You can use gluten-free flour. Just remember that's going to soak up more moisture. So you probably have to adjust the ratios of your milk. And remember there's xanthan gum, which is what the leaveners will react with in the gluten-free. So you may have to adjust that by adding a little more leavener. But thanks so much for watching the Buttermilk Assignment on Schoology. Thanks so much, everybody. Have a great day. Keep cooking. Let's go date her.
Live, and definitely not pre-recorded. This is Math Class Live with Mr. D. Hey, I'm Mr. D, and today our lesson is on growing and growing. What I need you to do right now is I need you to go and get something to write with and something to write on, because for the next 20 minutes we're going to be discussing exponential growth and learning about exponential growth, and I want you to work along with us, okay? So while you go and get something, if you don't have it already, I'm going to describe what we're going to do today and what you're going to learn, okay? And then we'll get on to the activities. Where are we at? There we go. All right, so what are we learning today? We are going to choose a better deal, right? And that's going to make more sense to you in just a second. All right, and what should you learn by the end of this lesson? So you should be able to compare growth patterns using calculations and graphs, right? What's cool about calculations is that they're calculations, right? What's cool about graphs is they're visualizations of what we're doing, what we do in the calculations, right? And so that helps us to understand things. And I think this is going to be a really fun lesson for you. I hope that you enjoy it. And let's get to it right now. All right, so our first activity is called splitting bacteria. No, this isn't, if you're coming in late, this is not biology class. This is math class. There are some bacteria in addition every hour. Each bacterium, that's a singular of a bacteria, if I'm correct, splits into 3 bacteria. The first question says, this diagram shows a bacterium in hour 0, right? Bacterium, singular. I'm sorry, this is probably confusing, right? So there's hour 0 and then hour 1. Hour 1, how many? There are 3, right? Because that 1 turned into 3 bacteria after 1 hour, okay? So we want to draw what happens in hours 2 and 3. And before you do that, you can't get started, but before you do that, I want to introduce the second part of this because we're going to do them concurrently, okay? Second part says, how many bacteria are there in hours 2 and 3? Okay, that's part 2, okay? So first we're going to draw what happens in hours 2 and 3, and then we want to make a table maybe of how many bacteria there are in hours 2 and 3. And so while you're working on that, I'm going to start doing some drawing. Okay, so I'm going to make a table and all that, but try to hit number 1 first. We're going to go over number 1 and then we'll go over number 2. So take that time now and I'm going to draw. How you doing? All right, I'm about ready. Okay, perfect. So our graphics department put something a little bit more more elaborate together, but let's hit this. So in hour 2, each one of these 3 bacteria from hour 1, right, split into 3 more bacteria. And so instead of drawing these all elaborate, I'm just going to draw little dots, right? So this one turned into 3 little dots, this one turned into 3 little dots, and this one turned into 3 little dots, okay? So what was 3 now became 9, okay? So now in hour 2, we're gonna go down to our table and we're gonna say that we had 9, okay? Then in hour 3, each one of these became 3. And instead of drawing that, maybe for the sake of time, let's just think about what happened here. So we had 1, it became 3 because we multiplied 1 times 3. And then in hour 2, it became 9 because we multiplied 3 by 3 again to make 9. So how many do you think that we had, or how many did you get for hour 3? 9 times 3, right? 9 times 3, which is equal to 27, okay? So you should have 27 bacterium there if you're playing along at home, and then we'll put that in the table so we know that in hour 2, this is answering number 2, we had 9 bacteria, and in hour 3 we had 27. And I'm obviously struggling with the singular bacteria, so we probably need to get on to another activity, but let's take a look at what our graphics department put together. All right, so here you go. So we've got our graphics department put all of these different bacteria together, put a table similar to what we did, and the question that we have is describe how is this growing. All right, so at home, I want you to think about this. You know, you've got a drawing, you've got your drawing at home, you've got your table presumably. So try to think about how would you describe this, and I'm going to go here to the text, and for the people that are online here, you know, I'm going to share some answers out. Okay, so I see Shalana from the West End, and Shalana from the West End says that they are multiplying. Very, very good. That's very, very astute. And we saw that in the last slide, right? We were multiplying each one of these, or however many bacteria we had, we were multiplying each time by 3. So that is very, very good. Shalana, let me see. Antoine West End, same thing. Good. All right. So so I mean, more or less, we are multiplying by 3 each time. Yeah. I guess we're probably not at the point where we're using the... Oh, there we go. All right, we got Trey Sean from the West End. He says this is exponential growth, right? And we'll talk more about this, but as opposed to linear growth, right? Linear, we're adding a number we call the slope each time. That's what makes a line straight, and that's what gives us a, you know, this sequence where we're using addition. In contrast, we use exponential. In exponential relationship, we're multiplying by a number. Okay, all right. So we're going to go on to activity 2. All right, activity 2, you are walking along a beach and your toe, hit something hard. You reach down, you grab onto a towel and pull out a lamp. It is sandy. You start to brush it off with your towel and poof, a genie appears. I should have drawn a genie. He tells you, thank you for freeing me from that bottle. I was getting claustrophobic. You can choose one of these purses as a reward. And I don't want it to be a gender thing. It could be a coin purse. You know, it does not have to be a female purse. So if you're a young man, you know, we'll just assume it's a coin purse. And if you're a young lady, we'll assume that it's a shoulder purse. All right, purse A, which contains $1,000 today. If you leave it alone, it will contain $1,200 tomorrow by magic. The next day, it will have $1,400. The pattern of $200 additional, or $200 additional dollars per day will continue. That's amazing, right? Okay, so let's just write that down. So each day plus 200. Right, and we were just talking about, I can't remember, somebody brought up linear functions, right? A linear function is when we add the same number each time. This is a linear relationship, each day plus $200. Right, so if we'll talk about it graphically later. All right, purse B, which contains 1 penny today. 1 penny. Right, that is literally a coin purse, right? And so, leave that penny in there because tomorrow it will magically turn into 2 pennies. Okay? The next day there will be 4 pennies. The amount in the purse will continue to double each day. All right? And this goes back to Shalana from the West End, her observation that we're multiplying each time. And so each day times 2, right? So dollars times 2. Okay. All right, so how much money will be in each purse after a week? All right, so what exactly does this entail? Well, we're going to start with what we have, right? So we got 1,200 here. We've got 1 cent here. And this is day 0, 1, 2, 3, 4, 5, 6, 7, right? And day 1, we are going to do plus 200. Day 2, we're going to do plus 200. Day 3, plus 200. Day 4, plus 200. Day 5, plus 200. Day 6, plus 200. Day 7, plus 200. Now, for the penny, we are going to do times 2, times 2, times 2, times 2, times 2, times 2, times 2. There has got got to be an easier way to do this, right? All right, yes, there's an easy way to do this, and let's just kind of back up. So for each one of these, we know how much we start with, right? So $1,200 and 0.01, so 1 cent. All right, and here we're adding 200, and then we do that 7 times, right? And so we're just going to put X, and we're going to let X equal days, right? And so after 1 day, we've added 200 1 time, right? So 1 times 200 is 200. After 2, we've added 200 2 days, right? So in this case, we've got a linear relationship where 200 is the slope, all right? For the penny, right, we are multiplying by 2 7 times, and we do have a convention for this. It's called an exponent, right? You should remember this from 8th grade. All right, so 100 times 2, and then we multiply by 2 1, 2, 3, 4, 5, 6, 7 times, right? And remember, X was equal to days, so when we multiply on the 7th day, we want to have multiplied by 2 7 times, and so we're just going to put an X here, right? So times 2, day 1, 1, times 2, day 2, 2, times 2, day 3, 3. And so we'd figure this out, on day 3, it'd be 0.1 times 2 to the 3rd power, right? But on the 7th day, right, which we're really looking for, we're going to try to calculate 1,200 plus 200 times 7, right? 200 times 7 is 1,400. So, excuse me, this is going to end up being $2,400, right? This is purse A. And then for purse B, we're going to calculate 1 penny times 2 to the 7th power, right? And since we're high school, we have calculators, and we're going to use a calculator for this. And we're going to end up with $1.28. So still not a fantastic deal to have that second purse, but we're going to move on. So we're going to take all of this out of here, right? And now we've got everything filled out. Actually, we've got the second part filled out too, and that was the after 2 weeks part. And maybe we'll go back retroactively and take a look at that. So remember that we had these two relationships. The one relationship was 1,000 times 200. Plus 200x, right? And this was the linear relationship where we're adding 200 each time, right? We've got a slope of 200. Every day that goes by, we add 200, right? That's a linear relationship where we're adding. Okay, in the second relationship that we had 1 penny. We multiply that by 2, and we do that as many days. So it multiplies by 2 as many days as pass. And so for 14, right, if we're trying to model 14, to find the $3,800 and the $163.84, we would do 1,000 plus 200 times 14 times, right? Because 14 days have gone by, we've gotten $200 14 times, all right? And we'll have 1 cent times 2, so doubled 14 times, right? Because that's what this function does, it doubles, right? And that got us $163.84. That gets us caught up to question number 2. Question number 2 says the genie later added that he will let the money in each purse grow for 3 weeks. How much money will be in each purse then? I tell you what I'm going to do. I'm going to give you a second because I think that we've got enough information here that you should be able to calculate each. So I want to give you time to try it before we give you the answer. And so the one conversion that we're going to make is 3 weeks, times 7 days in 1 week, right? So the weeks cancel out. 3 times 7 is equal to 21. And so what we're looking for is we're trying to find how much money is in each purse after 21 days. So take a few moments, try to calculate these out, and let's see what you get. All right. Do you have enough time to do that? All right. So let's take a look at how we set this up, and then we're just going to use a calculator to calculate this. So Now we're looking at 21 days. We are just going to take these two relationships that we had. So for purse A, $1,000 we started with. And then each day we got $200. And we are trying to find out how much money after 21 days. So we're going to multiply that 200 by 21. And we are going to end up with $5,200. Not too shabby. All right, I'll take $5,200 most days. All right, and then for purse B, right, again, we were multiplying. So we started with 1 cent, 1 penny, and we multiplied that by 2. It's easier just to use parentheses, okay. So we're multiplying that by 2, and we're doing that 21 times, right? Because it multiplies by 2 each day. We're looking for 21 days, so we're multiplying by 2 21 times, okay? And when I multiply 1 penny by 2 21 times, I get $20,000. Hopefully this isn't a surprise to you. Hopefully this is what you got, right? $20,971.52, right? 52 cents is fairly insignificant compared to the $20,000 that you're getting. That is amazing. And so all of a sudden, that penny after 3 weeks has become quite valuable, which is pretty awesome. All right, let's go on to this next problem here. Okay, so the last question says, which purse contains more money after 30 days? Right? And so we should be able to use our understanding of the relationship here, or the equations that we have, the rules that we have for each purse in order to solve this fairly quickly. Right? And so again, we started with $1,000 for purse A. We added $200 each day. We did that 30 times for the 30th day, and we got $7,000. And now we're probably gonna feel some buyer's remorse, and I'll tell you why. Because we already had $21,000 9 days ago with our penny purse, right? So let's figure out how much is in the penny purse. So 1 penny times 2, and again 30 days have passed. We're going to multiply by 2 30 times, right? That's what that exponent means. It says multiply this by 2 30 times, and the grand total is $10,737,420 and probably some change. Okay, so yeah, that's wow. I think purse B contains more money, just to answer that question. All right, there we go. Yeah, and there's the change right there. All right, we're going to go on to activity 3. And what activity 3 does is it takes this purse problem and it actually gives us some graphs for it, right? So now we're going to evaluate these graphically. So here are the graphs that show the amount of money in the purse as the purse has changed. Remember, purse A starts with $1,000 and grows by $200 each day. Purse B starts with 1 penny and doubles each day. And the first question says, which graph shows the amount of money in purse A, and which graph shows the amount of money in purse B, and explain how you know. All right, so take a second and take a look at these graphs and see if you can tell which one shows the amount of money in purse A, right, where we're adding $200 each day, and which one shows the amount of money in purse B when we were multiplying by 2 each day. All right, what do you got? All right, if you said that red is purse A and blue is purse B, you were correct. And explain how you know. So I think probably the most obvious giveaway, right? Since we haven't, unless you know about exponential functions, the most obvious giveaway is that red is a linear function, right? And we know that this $200 each day is the slope of a linear function. I'm adding $200 each day, so that is linear, okay? And we're going to get very, very familiar with this other form, and this is an exponential graph. Oh boy, and that is an ugly drawing. I need to get out of this slide immediately. But anyhow, that is an exponential graph, and we'll get used to that form if you're not accustomed to it already. But just take a note at the difference between the linear form and the exponential form. And you may also have thought back to the table and said, hey, I know that the red had more money until one point, and then the blue had more money. So it could be something as simple as that. All right, points P, okay, so here's point P right here, and Q are labeled on the graph. Explain what they mean in terms of the genie's offer, okay? Well, we're going to speed through this really quickly, but I want you to take a quick Okay, so tell me, but pay attention to the x-axis here. Right, so what is the x-axis? The x-axis is the number of days. And so we would interpret this in terms of the number of days. So point P here, right, is how much money is in the penny purse or the exponential purse on day 9, right? And point Q here is how much money was in the, what we call it, the $200 purse, the linear purse on day 5. Okay, and it's as simple as that, right? We could find values if we calculated them, but really what they mean in context is just the amount of money and the number of days. All right, and what are the coordinates of the vertical intercept, right? And another word for vertical intercept is y-intercept. What are the coordinates of these 2 points right here? Take a second and think about that. All right. You have an idea? Well, here it is. So this is where x is equal to 0. This is where time starts. And so this point right here in the $200 purse is 0, 1,000 because we started with $1,000 there. In the penny purse, this is 0 because time is equal to 0. That's the start. And there's 1 penny in there. All right. So those are the vertical or the y-intercepts for this graph, right? And that's an important feature of an exponential or a linear graph. Very important to know. And when does purse B become a better choice than purse A? Well, if I follow these graphs, right, purse B is worth less than purse A until right about here. Right, so this is 16, 17, 18, 19. Right, so on day 19, right, x equals 19, all of a sudden, my penny purse becomes more valuable than my $200 purse. All right, purses, right? All right, we are running behind as one of the problems of doing a live show, right? So we're gonna go right to the end. So I appreciate all of your hard work today. There's a quick introduction to exponential functions. We're going to do a lot more of it. It's going to be really fun, but what I'm obligated to tell you is that all of the music used is licensed under Creative Commons license. All of the music is listed here. And I want to thank you students for all your hard work during distant learning. We appreciate your efforts, and I know I speak on behalf of every single teacher that you have in telling you that we would much prefer to be in a classroom with you every single day, seeing you, and we really appreciate your patience. And this is a very important time, and we regret that we can't be together. But I appreciate you coming here and spending 20 minutes with me. Come back early and often. All right, have a good one. Thank you.
Hey, I'm back. I just wanted to do a real quick video, as we talked about in my last one, my sourdough start. So a few weeks ago, I started this. I started with this flour right here. It's an unbleached all-purpose flour. And for like a week, I didn't have very much traction. I didn't have very much traction at all. And then I went out and I got myself some whole wheat flour, and I added that to my sourdough start. So when I did my feeding, I just did 50 grams of that with 50 grams of water. And 50 grams of my other start, which would quite frankly was starting to smell like alcohol. I was trying some other types of flours, and they weren't working. So I went ahead and grabbed some of this whole wheat flour. A friend of mine who is an amazing baker, and his bread is great, kind of gave me some tips and tricks of what I could try. I looked up a bunch of other videos online, so you can probably, if you're searching for videos and you found mine, oh, I did this already. All right, so I grabbed a couple other things to feed because I was reading, and that's a good thing to do to learn more about it. So I grabbed some. I'm gonna grab my little scooper here. I'm gonna grab a new jar here. I usually mix it in a bowl. All right. I want to have a couple of things. Awesome. Live. Unprepared on the remote here. All right. So some things I'm going to do is I'm going to take my knowledge. I'm going to drop my little notepad here. The jar I'm using is 425 grams. I don't know that. I'm going to tear it out. See how far off it is from my bowl here. All right, so I've been feeding it now this flour. This is semolina flour, great flour for pasta, great flour for bread. So I'm going to take 50 grams semolina flour. Here, I'll move my camera so you can see. 50 grams. 42. And it doesn't have to be precise. That's 52. 52 is good. Put this back in my safe bag here. All right. And I'm using bottled water because I have a whole bunch of it. But then I just refill these with the filtered water off of my refrigerator. So I've been using these same 2 bottles of water for a little bit. But I keep them at room temperature, not in the refrigerator, and it doesn't need to be warm. So I'm going to get this up to about 100 grams of flour and water together, 50-50. Stir that up. And remember, I talked about how the yeast comes out and how it gets from everything. So naturally, yeast lives in the air, right? So when I took this bowl out of the cabinet there was some yeast floating around in there on my bowl. There's some yeast on my hands. There's yeast everywhere all the time. All right, so we got our bowl zeroed out. Now I'm going to get my starter here, which is just bubbly and oozy and so happy. Look at that. That's awesome. And it smells like fresh bread. I'm going to go inside of here, and I'm going to get 50 grams of this. So I zeroed out my scale. Here we go. I'm going to get 50 grams. It's 25. And 38, 41, 46, 50. All right. So 50 grams. And literally, when you're done with this, it's sad. Normally, you would bake, and I would use the rest of this in my baking. But I've just been feeding it, it kind of goes to waste. And it's a sad part, which is why I started a second starter in my refrigerator, because I felt bad, and now I have 2 starters going, but one I keep room temperature, one I feed every week. So you just discard the leftover. You don't keep the leftovers. All right, and so then I'm going to take this. These are the 2 ingredients. I'm going to mix those together nicely, and it's going to add more moisture. You could increase or decrease the moisture content. You can start playing around with that as you go forward. I'm not going to. All right, so we've got our jar here. It's 425 grams. I'm going to actually use that for later tomorrow when I weigh this in the morning and I feed it. So what's going to happen is I'm going to go ahead and place this start down in there. And we should have pretty close to about 150 grams. Now, like, we lose a little bit along the way. Stuck on the jar, stuck in the bowl, but that's get that kid down there to play. Give them all the food they can have. That's good. So the last thing I do here, I'll do it on this. So smash it down a little bit just to try to get it down. I've got my cloth lid I'm going to put on it, and because I am constantly watching my start, watching my start, I go ahead and I'll mark my dish where my sourdough. Now, that's really probably not correct. It's probably closer to like right here, as in a cup. All right, 150 grams. I think it says it right there. 200 milliliters. It's probably 150 milliliters or 150 grams. Metric is super easy to convert like that. So there you go. It's fed. I'm going to let this sit. Time's at 12:34 tonight, so sometime tonight or even tomorrow morning, maybe, because I let this go longer than 12 hours so it could eat up as much as it could eat up. But yeah, there you go. Easy peasy pie. This is actually going to go on for a few more weeks before I actually make bread with it. I want to get this starter nice and going that I can put basically any flour in there and let it eat it and go, with the exception of bleached flour, because you think about it, it kills out any bacteria and stuff. So I'll eventually move from the semolina, which is that really, really rich flour, which is making a really awesome start in here. But I'll probably start throwing in some all-purpose and some other things like that just to feed it along the way for cost's sake, because that's expensive flour. But yeah, so get yourself some, if you can, some whole wheat flour or some unbleached all-purpose or bread flour. You don't want cake flour because typically cake flour has cornstarch mixed into it a little bit. But bread flour is good, super high protein content. All right. So thanks for watching. This was a quick update on my sourdough start, and we fed it, and there it goes. That's it. Have a great day. Thanks for watching. Go Cougars.